Hello, welcome to the episode number 9 of Implementing Exceptions with Ruby. My name is Erland Wilkinson, I work at 10 Pines, and remember that we are implementing a new model of exceptions with the Ruby language using only objects and messages. On the last episode we implemented some features in our model that are not available in most programming languages. We could implement these features because our implementation is open. It uses just objects and messages. There is no special syntax, no special VM support, and that's why we could implement these new features that we needed. We have some to-dos that are in our list, and the most important ones are related with the issue that we're still using some class instance variable in two places. The first one is the handler not found strategy, and the second one is on define handler on the define exception handler class, where we have a last handler that is a class instance variable. And the problem with having a class instance variable for that is that we cannot have more than one list of handlers in our system. That means that if we have two or more threads that are installing different handlers, the things are going to get mixed up. So we need to get rid of these class instance variables, and so we're going to make our implementation thread safe. So to do that, we have to write our first test that is going to show that our implementation is not supporting multiple threads. And to do that, we're going to have to implement some, we'll have to use threads. So let's create a thread that is going to have a block that is going to signal or throw an exception, and is going to handle that exception with some handler. Exception that is going to do something, we'll see what in a minute, and then we will need another thread that is going to do exactly the same thing. But what we want to test is that in this thread, when we install the handler for new exception, if we throw the exception, we want to show that it's possible for that exception to be handled by this handler, and that is wrong. It should be handled by this one. So to make that happen, we will have to put some synchronization between these two threads. Well, the first thing that we want to do is that we want to identify when a handler is evaluated. So in the first thread, we're going to return 1 if the handler is evaluated, and in the second one we're going to return 2, and we're going to keep that result in a variable. So let's call it thread1 result, and here we're going to use thread2 result. So our assertion is going to be that we want we want 1 to be thread1 result, and we want 2 to be thread2 result. But for this to happen, first we have to wait from the first thread to finish and the second thread to finish. So let's save those threads let's reference those threads in these variables, thread1, thread2, and let's do a join here of thread1 to wait for it to finish, and the same with thread2. Okay, so now we have our test. It's almost done, but we have to do some synchronization between threads. And what's the synchronization? Well, when we start the second thread, we want to be sure that in the first thread there is a handler that is already installed. So here in thread 2 we're going to pass while not in call handling on thread 1. Call handling on thread 1 is going to be set to true. It's going to reference true when we get inside the call handling message, when that message is sent and the block that received that message is being evaluated. And we have to initialize this to false to be sure that it is false from the beginning. Okay, so now thread 2 is going to wait until thread 1 is here, and when thread 1 is already here, we have to wait for thread 2 to install the handler. So we're going to do exactly the same thing. We're going to pass while not in call handling of thread 2, and we're going to make that variable to reference true when we are evaluating the block, and we have to initialize that to false. Look how difficult it is to test concurrent things, and sadly Ruby doesn't provide us semaphores to be able to write this test a little bit nicer. But anyway, we have now thread 1 waiting for thread 2 to be evaluating the message call handling, the method related to the message call handling, and now when we are here, we want to throw this exception. We want thread 1 to throw the exception and see that the handler that is evaluated is this one. So what we're going to do is we're going to stop thread 2, therefore this exception is going to be thrown, and then we hope this handler to be evaluated, and that will show us that there is an error. Of course, because the thread 2 is stopped, we will have to make it run somewhere. So from here, thread 2 will receive the message run to end its execution. Okay, let's see what happens if we run the code, the test. Okay, we're getting an error on test file that is an unexpected return, and we're getting this unexpected return as we did on episode 4, I think, or 5, because for some reason we are returning from this method called handling when using a continuation that is not and the method called handling when was returned already. So we're trying to return from a method that already returned, and that is because exactly our implementation is not thread safe. So we're going to make our implementation thread safe, and before doing that, let's avoid running this test, because as you can see there are other tests that are failing because our model is mixed up. So we're going to make a change in our model. Remember that to make changes in your design you have to be sure that all tests are running. Let's run all tests, they run, and now we can start making the changes. So what's the problem? The problem is that our implementation is not thread safe, and that's because we have last handler as a class instance variable, and we need this to be a related per thread. So before starting to making this change, we should be able to make a refactoring and to encapsulate last handler, but sadly there is no refactoring on RubyMine to do it automatically, so we'll have to do it by hand. So let's create a method, a class method for last handler that is going to receive a handler, and is going to set last handler with the parameter handler, sorry. And now let's change all senders, all reference to the last handler variable to send the message. We need to change it here, and where, and here, and I think that's all, and here, sorry. But also we need to change the references when we are reading that variable. So let's create the method last handler that is going to return last handler. And now let's change all references to that variable and send the message last handler. And here. Okay, self last handler. Let's see if we make this change correctly. Yes, all the tests are working. So now we are in the condition of making this variable thread related per thread. So let's do thread current, and let's use a thread variable that we're gonna call last handler. And now let's do it here, thread current last handler. Remember that thread variables are variables that you can define like in a hash per thread. So now last handler is not going to be referenced by a class instance variable, but by a thread variable in the current thread. Let's see if everything is working fine. Everything is working fine. So now we can see if the change we made is enough to make our test pass. So let's run the test, and now we have an error, but the error is on the test. And this error looks weird because it's saying that thread 2 is not defined, but thread 2 is defined here. What is the problem? The problem is that inside this closure, thread 2, because Ruby doesn't, because in Ruby we don't need to define the variables, Ruby thinks that thread 2 is a variable inside the closure and not the variable that we define in the method. So we have to define thread 2 in the method. Let's make it reference nil. We have to define thread 2 in the method to make this thread 2 variable be binded with the thread 2 variable of the method. Let's run the test. We have the same issue with thread 1 result and thread 2 result, and that's because again those are referenced or defined inside a closure and not in the method. So let's initialize those to be equal to 0. And now let's see if the test runs. And yes, it runs. So great. We have our implementation that now looks to be thread safe. And we have to get rid of the handler not found strategy, that it is also a class instance variable, but in unhandled exception, in the unhandled exception class. So let's start writing our test that verifies that that is not working. Test 6. Remember that we are not worrying about the name right now, and we will have to do something very similar to what we did in the previous test. We will have to have two threads. The first one is going to set the unhandled exception handler, the unhandled exception handler not found strategy, sorry, to be something that will return, for example, 1. And now we're going to have an exception that is thrown. We don't need to create the lambda there. We're just going to do new exception throw. This is something that we haven't tested, but you will see that if an exception is not inside, if an exception is thrown but is not inside the call handling method, it will anyway throw the unhandled exception, and therefore the handler not found strategy is going to be evaluated. And we want the new exception throw to return 1, so result, again we're going to store that, reference that in result thread 1 variable, or let's write it the same as before, thread 1 result equals this. And now let's have the second thread that is going to return true, 2, and again we want almost the same thing as in the previous test. We want to join for those threads to finish. We're gonna wait for those threads to finish. Okay, cool. And we want to assert that the first thread returns 1 and the second returns 2. We need to define thread 1 result and thread 2 result as in the previous test to be equal to 0, so that Ruby takes those variables from the method and not from the closure inside the thread. Okay, what else we have to do? Well, we have to be sure that before installing the handler not found strategy in this thread, that the handler not found strategy was set in the thread number 1. So the first thing that we have to do is something very similar to what we did in the previous test. We're going to pass while not handler not found strategy set on thread 1. We're gonna set this, reference this to true, this variable to true when the strategy is set on thread 1, and initialize that to false. Okay, and now that we're sure that strategy is set on thread 1, we will have to wait here on thread 1 for the thread 2 to set that strategy. So we will have to reference the variable handler not found strategy thread on thread 2 to true here. Okay, and we will have to initialize that variable to false at the beginning. Okay, so again we see that this is kind of difficult, but you know, we're doing this step by step, so it looks like it's going to work. And after we have that strategy set on thread 2, we'll have to stop the current thread, the thread 2, to be sure that this exception is thrown. So when this exception is thrown, we want to see that this handler is evaluated and is going to return 2 as a result, and that's the error. And after this we want thread 2 to run, to keep running. So we have to define thread 2 here in the method, so it takes that variable instead of thinking that it's a new variable in the closure. Okay, I think the test is written correctly. Let's see what happens. We got a deadlock. Let's stop the test and let's see why we got that deadlock. Okay, there must be an error in the implementation. Let's see oh yeah, the problem is here. This should be set after setting the handler not found strategy. Let's run the test. Now it's not a deadlock, but we are getting another error that says handle message handle set to send to nil. And that is because I think we have another error. And yes, that's something that we didn't realize when we changed the code to be thread safe, and that's that we are initializing the last handler only once, and now that we have to do it, we have to do that per thread. So let's change when somebody asks us for the last handler, let's return the last handler, but let's do this. If it's not initialized, let's initialize it. Initialize last handler. Okay, so let's remove that from here. Let's run the test. Yes, now it's running, but test 6 is failing as we expected, because it's returning 2 instead of 1, and that is because it's mixing the handler not found strategies. Okay, cool. So now we have to make it work. So let's go to unhandle exception, and let's do the same thing as we did before with the thread. Handler not found strategy should be set per thread. So let's thread current handler not found strategy. We have to set it here, and when we want to access it, we have to send the message. So we have also to define handler not found strategy as a method. As a getter, we have to have the getter, and that is going to be initialized also the first time with the default handler not found strategy. Okay, so and let's see where in another place we're using it. We are not using it anywhere else. Let's run the test, and now all the tests passed. Okay, so what we did is our code to be thread safe. They are not using class instance variables anymore, so this to do is done, and there is one to do left that we're not going to cover on this episode. So what we did on this episode is to see that from the language point of view, Ruby has some ambiguities on the syntax, or let's not say ambiguities, but you're expecting something like referencing a variable inside a method, but that variable is initialized in a closure, and because a closure has also its execution environment, then the variable is defined inside the closure and is not using the variable that you think that you are defining in the method. So be aware of that. And from the design point of view, we have now exception handlers and the unhandle exception strategy related with the thread. We don't have that in class instance variables anymore. And from the TDD point of view, remember that you should not modify your design or your implementation when tests are failing. That's why when we decided to make the change to be thread safe, we renamed the test that was failing to have all tests working and then make the change. Remember that testing concurrency is very difficult, and that lead us to the latest conclusion, that is that the test has to be in control of everything. Every time you write a test, the test has to control everything it needs for the test to run. In this case, the test had to control how the threads run, and sometimes you have to write tests where the test has to be in control of how the time passes or how you communicate with external systems like databases or any other kind of external system. So I hope you liked this episode. We are getting to the end of this set of videos, and the next one is going to be the last one. So I hope to see you there.